Today we're looking at this Sharp microwave oven, trying to do a repair. Now the oven itself works fine. The repair itself will be limited just to the display, which hopefully we should be able to see has some missing segments. It should be displaying 000, and it's already a problem, and we can see that there's 1.5 things illuminated at the top instead of just one display. Here's a composite with several settings, and some of them are pretty unintelligible and some of them make no sense at all. Apparently doing popcorn, vegetables and pizza all at the same time, so not much use at all. Worst case scenario, we have to get a spare part for this. Best case scenario is that this is just some problem with the lines from the microprocessor to the display, maybe some bad connections, or possibly the display itself, maybe some diodes shorting out or something like that. We'll crack it open and see what we can find out. Okay, so just 2 screws on the side and 4 on the back, and it's all opened up. We'll start off with the fan at the right hand side, open frame motor. Not sure I'm too keen on that, but I guess it keeps it cool at least, but I would have expected something more than that. Here we've just got a normal input circuit, so we've got a common mode choke, some Y and X class capacitors and fuse. Nothing much going on there at all. Obviously some earth connections, and we've got an element in the back for the oven, an element in the top for the grill. Moving across, we've got a thermal cutout there on the main oven cavity and a thermocouple. So this is a thermal cutout on the microwave unit, and there it is itself. And big power supply, big transformer, and equally large capacitor for the microwave. So moving across, we've got the circuit boards. So the bottom one is just a rotary encoder. Above that there's a few switches, but they're behind that circuit board that's above. And pretty much it's just simple relays connected through to everything. So this is a pretty basic board. I think there's probably a microprocessor on the other side, and mainly what we're seeing there are the resistors coming through to the display. So that's about it. I'll pull the board and we'll take a look at it. Remember where all the cables go, so I'm just going to take a quick run through this board, I think probably from right to left. So just here we've got the mains in, so live neutral earth, and this section here is obviously just a little switch mode power supply. So we've got mains rectification going on here, and then a little controller is chopping that up through here, and just a filter capacitor on the output. Up at the top we've got the buzzer. Oh dear me. And just here we've got all the relays. So we can see microwave, grill and convection oven relays just there. And over here we've got a fan and something else that I can't quite make out. So that's all fairly straightforward. This will almost certainly be a driver chip for those relays. Along here, and maybe just here, although I think that those belong to the relays. So along here of all the resistors going across to the display, and we can see the pin out for the display sticking through just there. This connector here is just for the keyboard. So we'll take a look at the other side. We should expect to find a microcontroller probably buried underneath the display unit. If we turn that over, we can see there's not a lot going on the board there. This section over here, of course, is all the high voltage section. These are the backs of the relays. That's all nicely marked and nicely separated. Plenty of separation on the PCB there. And then just here we've got our custom LED display. On the right hand side of that are all the leads running up to it. There are a few transistors down here, which are probably the commons, because there's probably a fair few commons in here. And there's not a lot down there. That's me just connecting through. There's another lead just here running up to the display, and inside, just underneath, we can just see a diagonally placed little microchip, probably an ST or something like that. So I'm going to just start off by checking some of those resistors on the back and just checking them across to the pins on the actual display, just to make sure the continuity is okay. Okay, so it's slightly tricky to do this without getting in the way of the camera. But I'm just going to check along the string of resistors here. So I think this string here is supposed to be 1Ks. We're doing this because we know the power's there. So now that we've tested all the resistors are okay, we'll check and see whether or not the pins on the display are actually connected through correctly on the board to the end of those resistors. So we're just going to pop the meter into continuity range, and we're just going to buzz those out. First, I'll have to try and figure out what the sort of pattern is for connecting. I can't see the offsets very easily of where the resistors are versus the pins. And looking as well, the soldering doesn't look that great. So that's resistor 3. Okay, so let's run across this. So we've got how much you're getting reading on a couple of these on the multimeter, which tends to indicate that it might just be going through the So if we count this as pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I found all the segments, and now I'm testing for the commons, which are unlikely to work. But what I've found here is actually a resistor that seems to be connecting through to the common as well as a segment. So resistor's okay, the continuity is okay. So now I'm just going to wick off the solder from the pins through to the display, take the display off, and test that in isolation. I think I do now begin to think that it's the display. The fact that I was getting readings connecting through from the common to segments, in some cases and not others, would tend to indicate that there is some breakdown within the actual display unit. We'll see once we get it off. The first challenge is to remove these really horrible solder joints, and they actually do prove quite tricky. There is a conformal coating on this, and it actually looks like they've put the conformal coating on and then soldered these connections on top of it. Overall, it's a bit messy. It's going to take a little while. On the video, I'm just going to cut through this bit. So I've set up the power supply to power the diodes so that I can test each one independently, and I've set it to 2.9 volts, 10 milliamps limit, so that hopefully I won't actually damage anything should I get a short circuit. 2.9 volts should give us a nice bright display. If it's too bright, I can just turn it down a shade. Here I've connected the negative to the first of the commons, and I've connected this probe to the positive so that I can easily get in there and just pick off the pins that I want to test. Okay, so this is fairly tricky because I want to try and keep my hands out of the way. Okay, there we go. So pin 1 gives us chicken. So that at least proves that everything works. There's pin 2, beverages. Pin 3, potatoes. Oh, and there's pin 4. So pin 4 is doing pasta, but it's also lighting up meat quite a lot. And so is pin 5. So my suspicion is that internally there's a short circuit there. Pin 6 is doing nothing. We've got pasta and meat again. More pasta and meat. And a very, very faint potato. 3, 4, yeah, and there we go. We've got 2 digits. It's 2 center segments of digits lighting up. Again. And we see the same sort of pattern. So it's definitely around those particular input pins. On this one, again, don't know if you can see, on pin 1, there's one segment, one bar graph item here, and then 2 faint ones further along. So it's definitively a problem with the display. I've taken a little bit of time on this board, hoping it was something simpler. I've checked all of the connections. They were my first suspicion. They were okay. I've checked the resistors. They were okay as well. But once I started looking at the display itself, I started seeing some strange readings with the multimeter, and then of course took it out and proved definitively that that's the problem. Now this display is potted. I can't get that out. It's just LEDs on a printed circuit board inside. If I could get it out, I could probably repair it. I've also thought about actually rebuilding the display from scratch. I can print it outside, for example, but the pinout presents quite a problem, and truthfully, is it really worth it? At this point, the actual build quality on this board is dreadful. I've looked for a replacement board and a replacement LED, and I can't get either. Well, not for any reasonable price. So if you've enjoyed this, please click like, please click subscribe, and I'll see you soon.